Okay, this is the review for rational functions test number 2. There are 18 questions on the test. Review has 18 questions. There's a 1A, 1B, all the way to 18A and 18B. I'm going to try to get all the A's done with you today. You're going to be responsible for doing the B's on your own. And this review looks awfully similar to the test. So here we go. Alright, first things first. The first one is a factor of a perfect cube, or sum of two cubes or difference of two cubes. The first one has a negative cube number here, which we have x to the third minus, and 125 is a perfect cube, which means we are going to do 125 to the 1/3 power, and that is 5. So this is minus 5 to the 3rd power. This x is my x, and this 5 is my y. Now we're going to match those up. This is a cube minus a cube, cube minus a cube. So we're going to use the bottom one. If it's plus, you do the top one. So first we have a binomial. The first binomial is x minus y. X is x, the y here is 5, and the minus comes from here. Now we're going to have a trinomial. It's going to be x squared. My x is actually x. Then we do x times y plus x times y. X times y, x times 5, that is 5x. And then we have a plus y squared. Y is 5. 5 squared is 25. You just plug those in. That is my answer. On the next one you see that's a plus. You do the same thing, except you use the pattern up here on the top one instead of plus there. 2a, find the quotient. So I'm going to go through, do all the steps for you, show you how this should look. I actually think the ones on the test are slightly easier than this one. So what we're going to do, first one goes in the box. It is very important for you to make sure you copy this right and you don't have any gaps in here. X cubed, there's the x squared, there's the x, there's the constant. And this last one goes outside. What has to happen is this binomial, we start with these first two terms for how many times they go inside. How many times does 5 go into 50? That goes in 10. Oh, you can't see that. I'm sorry. First one in the box, second one outside the box. We're looking binomial, binomial. Which one goes in the box? 10 times 5 10 times 5 is my 50. See how they're matching here? X times what gets us x to the 3rd? This has to be x squared. X squared times x, x to the 3rd. Then 10 times negative 4 is negative 40. And x squared. If you notice, everything on this column is going to be x squareds. Everything in this column, x cubes, x's, and constants over here. Everything's going to be nice and lined up. Next, we're going to go through and change my sign. So this positive becomes negative. This negative becomes positive. These should now be 0 pairs. Those should now be 0 pairs. Those disappear. 10 plus 40 is 50 x squared. Again, all these will be x squareds if everything is done right. And then we need to bring this down. And we repeat our process. We have a new binomial. Let's check my terms up. How many times this first term goes in the first term down here? 5 times 10, so plus 10. So 10 times 5, that's my 50. Matches so far. What do I have to multiply x by to get x squared? Need an x there. X times x is x squared. So that's identical. Now I'm good. 10 times negative 4 is minus 40. And x. Next, I have to subtract. Positive becomes minus, minus becomes positive. Those are zero pairs, everything's working well. Negative 35 plus 40, that gets us 5x. Bring down the negative 7. And we start over. Look and see how many times it goes in. 5x into 5x, that's pretty easy. Plus 1. 1 times 5x, 5x. 1 times negative 4, negative 4. And the last step, we are going to subtract. Those zero pair, everything's working fine. Negative 7 plus 4, minus 3. This minus 3 is our remainder. And your answer is the top part, 10x squared plus 10x plus 1. And then this remainder is a minus 3. So I'm going to say minus 3 over 5x minus 4. You can do 2b. For 3a and 3b, you're doing the same thing. I'm not going to have you do these. These are the only two on here you don't have to do. The problems are not put in correctly. So only thing we're going to do is set these up. That's the only thing I'm expecting you to do is set these up, not finish these. First, excuse me. First one goes in the box. 2x to the third plus 9x squared. I'm missing an x term. I have to put in an x term. So I go plus 0x plus 15. Second one goes out here. And the process will be the same as this right here. But we're not going to do this one. This problem I don't think was copied right. Same thing with 3b. Please set that up properly. Look for missing terms in there. For A, we are going to simplify. We are going to show all the steps to simplifying. Where's my paper? Okay, my steps. Okay, first thing, we are going to switch this around. What do I need to do? So when I'm dividing, I take my first fraction. I change the division to multiplication and flip this around. At this point, if you wanted to, you could just multiply across. Your number's going to get fairly large because you can simplify. So what we typically do is simplify before going on. This x minus 5 and this x minus 5 can cancel. Anything that cancels is a 1. So what we end up with is 1 over x plus 3 times 3x plus 1 over 1. When we multiply across. 1 times 3x plus 1 is 3x plus 1, x plus 3. This is my final answer, but all of these are equivalent. All of these things are equivalent. So if you're having to figure out which is equivalent, just work the steps and see which ones match. 5a. Similar idea, but there's more terms in this one. First thing we're going to do is remind ourselves that multiplication or division are done left to right. So we're going to take care of these first. I highly suggest we simplify. You can also change this to multiplication. For example, 16x to the fourth, x to the third, y, times x to the fifth, y to the third, times 2y to the seventh, 5x to the third, is the same thing. We just switched that division and made it multiplication. That is perfectly fine for you to do. If you wanted to, I'm actually going to work this two ways. You can multiply all these across. 16 times 2, 32, x times x to the fifth, x to the ninth, y to the seventh. What is this? 5, x to 3 and 3 is 6. Y to the third, you can get that, or you can cancel. You can cancel. To cancel this, see what works to cancel here. So we have x to the third, x to the fourth up there, x to the third here. So if I cancel this, left with the 1 there, x to the third here, I take 3 from this and end up with 2. Then I can cancel y's. I can take 3 from this, that'll make that 4. I can take 1 more and make that a 3. So I now have 16. And what else we have? Nothing else. 16 over 1, x squared over 1, 2y over 5. And if I multiply this out, I get 32 x squared y. Wait, that's not right. Oh, that's a 7 over 5. This should be a 4. Oh, that's a 3. Okay, this is a 3. Hold on. Y, 3, 7. Okay, yeah, that's right. This is wrong. This y and this y, that means that that's a 4. And these are all equivalent. This, and this are all equivalent. So if your test asks you for what's equivalent, you could have this one, so this, what I hadn't read originally, this one, or this one, are all equivalent to each other when I work these steps. I'm doing it this way to help you on your test. Yes, I know it can be done simpler. This is going to help you for your test. Okay, matching. We're going to find least common denominators. Your least common denominators on this are fairly simple. You're going to have multiple choice. If it's not a fraction, if it's not already a fraction, make it so. X and 1, least common denominator is an X. X, 4, and 4, get all the factors that are uncommon, unique. Don't need the extra 4 here. X and 4, least common multiple is 4x. X plus 2, there's 2x plus 2's. I can ignore the x plus 2. I have 3 and x plus 2. That means my least common multiple is 3x plus 2. And the last one, they're the same. 9b is a little different. They're different. So I'm actually going to do 9b for you. This would be x plus 1, x minus 4. Simplify each expression. What are we going to do to simplify each expression? The expression. Well, the first thing we need to do is figure out my least common denominator. To find my least common denominator, I need my factors. Factors of x squared minus 16. It's a difference of squares, x plus 4, x minus 4. So that's this one. This is x minus 4. I don't need my x minus 4 twice, it's already listed. So this is my least common denominator. This term over here already has the least common denominator as its denominator. Nothing's going to happen to this. You see how nothing happens to it? But I have to make this one with the least common denominator. How am I going to do that? I have to multiply this by my missing term here. I have to multiply the top by x plus 4 and multiply the bottom by x plus 4. That gives me my matching bottom, x plus 4, x minus 4, and the top I have x minus 9, x plus 4. That's my first step in solving this. I have to multiply this second term by my least common denominator, whatever's missing from my least common denominator, so I can make this my least common denominator. Okay, 11a. 11a. We need to figure out when this is undefined. I'm going to go ahead and factor the second one. So we see that, hey, look, these match. If those match, we only need to look at one of them. Where does x minus 5 equal 0? To figure out where x minus 5 equals 0, we set it equal to 0. Add 5 to both sides, x equals 5. That means it is undefined at 5. (12a). In order to solve the equation, what step would you do to remove the variables on the denominators? To remove the variables when we're solving, we multiply all the terms by the least common denominator. You multiply all the terms by the least common denominator. The least common denominator in this case, well, let's go ahead and figure it out. Can't factor anything here. Can't factor anything there. Oh, here, let's check these. So, one factor, 2a minus 5. This one's different. 2a plus 5. This is a difference of squares, so that's going to be 2a plus 5, 2a minus 5. Those match, 2a plus 5, 2a minus 5. I don't need them if they're not unique. This is my least common denominator, so I need to multiply all my terms by my least common denominator. So this is going to need multiplied here, it's going to need to be multiplied here, and it's going to need to be multiplied here. Multiply all the terms on both sides of the equation by 2a minus 5 times 2a plus 5. That's the first step. 13a, let's solve an equation. 13a is a super simple one. If you look at the bottom of the equation, you have the same denominators. If the denominators are the same, it makes our life a lot easier. 13. Same denominators makes our life a lot easier. So if they have the same denominators, I don't need them anymore. I can simply say 4x is equal to 20 minus 6x, and I solve it like any other equation. I like to get rid of the smallest x first. Plus 6x plus 6x, 10x equals 20. Divide by 10. X is equal to 2. For 14a, we're actually going to have to do a little bit of work. Just like we talked about this when we solved the equations, we have to multiply by the least common denominator. So in 14, we're going to multiply everything by the least common denominator. What is it? Factors of x, we have x. Factors of 2x, we have 2 and x. We already have a 2, so I keep it listed. And 2. Alright, so my greatest common factor is 2x. So I need to multiply everything by 2x. 2 times x. All of this times 2 times x. And then this times 2 times x. This x and this x cancel. That x and this x cancel. That's how the bottom goes away. And I'm left with 2 times 2, which is 4. Now, this is 2x and this is 2x, which means those cancel completely. And I'm left with this negative times this. So I have negative x plus 28. It's subtraction. We have to change the signs. Equals this 2 and this 2 cancel, so I have 15 times x is equal to 15x. And my last thing to do is simply solve all that. My smaller x is over here. Add x to both sides, so I get 16x. Combine those, 4 plus 28 is 32. Divide both sides by 16. 2 equals x. (16) is another solving one. Is probably a little bit more difficult because we're gonna get more than likely the fraction answer because it's just a little bit more complicated. Least common denominator is going to be 4x squared. 4x squared. So when I multiply these by 4x squared. 4x squared, multiply by 4x squared, multiply by 4x squared. 4x squared is going to cancel. I have x plus 6. The x squareds are going to cancel. 2 is only going to cancel once, though, so I need 3 times 2, which is 6, so plus 6 again. Same thing here. The x squareds are going to cancel. The 2 is only going to cancel once, that's 2. So I have equals 2x plus 8. And I'm going to solve that equation. I have x plus 12 is equal to 2x plus 8. Smallest x over here, subtract it from both sides, x, subtract the 8 over here. 12 minus 8 is 4. Don't forget, which I have not been showing on here, check your answers to make sure that works in here. Can I put my 4 in here? 4 works. The only thing this can't be is 0. Did I check these? So go back to 13. Let's check this 2 on 13. I totally forgot to do this. If I put 2 in here, what's going to happen? This is going to go to 0 and make this undefined. So this one actually has no solution because that would be undefined. Sorry, I forgot to do that. My fault. Please don't forget that on the test. Okay, now we're going to go to 16. If I look at 16, 16 looks kind of complicated. Least common denominator is going to be pretty straightforward. It's going to be 20. I'm going to multiply these. So my least common denominator is 4 times 5. When I multiply this side times 4 times 5 and this side times 4 times 5, the 4's cancel. And I'm just left with multiply by 5. Here the 5's cancel. What I would like you to do first, which I didn't do, but I would try to do first, is simplify everything in here before you multiply by 5. I can distribute this and then add that. So 3k minus 6 plus 2, and we're still going to multiply that by this 5, is going to be equal to, and here this is negative, so we have 5 minus 3 plus k. These are changing the signs, but I still have to multiply it by that 4. Before I go on, I'm going to keep the 5 here. I can combine those two. 3k minus 4 is equal to 2 plus k. I still need the 4 here. Now I can distribute 15k minus 20 equal to 8 plus 4k, and I can simplify that as I need to for to solve. Smallest k is over here, so I'm going to subtract 4k. 15 minus 4k is, I'm going to go over here. What is that, 11k? Minus 20 equal to 8. Then I can get rid of that minus 20 by adding 20 to both sides. So I get 11k is equal to 28. And the last thing I'm going to do is divide by 11. K is equal to 28 over 11. Okay, second to last one. I'm going to look at my graph here, or sorry, my table. It wants to know where this is equal to 1/3. This right here is my output. That's my Y1. Which one of these is 1/3? That's this one. So my answer here is 5. My x equals 5. And we're going to move on to the last one. Okay. We need a common denominator. Let's try to find my common denominator. Factors here, we have 3x squared, 2x squared, and x. That means my least common denominator is going to be 6x squared. So I have to multiply everything basically by 6x squared. I'm going to break all that out for us. So I have basically 6x squared over 3x squared is equal to 6x squared over 2x squared minus 6x squared over 2x squared. I'm sorry. That's just x. What cancels here? Those cancel completely. I'm left with a 2. Those cancel completely. I'm left with 3. This is just x. So minus 6. Nothing cancels 6. And the x only cancels that out once. An easier way to see that is that's the math. You could also see this as, what do I need to multiply 3x squared to get 6x? Well, I need to multiply this by 2. Well, 1 times 2 is 2. There's this 2. 2x squared is 6x. I need to multiply that by 3. There's that 3. X to 6x, I need to multiply it by 6x. And it's minus, so negative 6x. And I solve that equation. Minus 3. So negative 1 is equal to negative 6x. Divide by negative 6. X is equal to positive 1/6. And that is all of the review. Please finish the B parts of this. The only one you do not have to do is, I think it was 3. Just set that one up.